Hi guys, down at NES. This is Mr. Manchester up at the high school. Hopefully I can help you out a little bit with Fibonacci series and sequences and give you a little bit of information. You guys had great questions. And it's been a while since I've looked at this stuff. We do it a little bit in school, very basic at the high school. Hopefully you guys can see this here. So obviously the Fibonacci series starts with 1, 1, and then what you do is you keep adding the previous two numbers. So if we go through and add 1 plus 1, that gets me to 2. And then how do I get the next number? Then I add the next two digits. 1 and 2 get me to 3. 2 and 3 get me to 5. 3 and 5 get me to 8. So hopefully get that, and that keeps going on and on forever. I didn't know until I saw it, but sometimes you can start with 0, 1, 1. I always thought it just started with 1 and 1. So a couple ways to get there. As I said, we look at this a little bit in Algebra 2 and pre-calculus and during different sections of discrete math. And discrete math is kind of the math that they can't put a topic on it and a name to it, so they kind of throw all sorts of stuff at it. And sequences and series are one of those. So where this comes up is in a recursive series, which, what does that mean? It means we have to know the previous term to figure out the next term. So for the Fibonacci series, they tell us the first number in the series is 1, that's S1. Second number in the series is also 1. So in order to find the nth term, I have to know the previous two terms. Well, what does that mean? The third term right here is going to be found by knowing, if we know the second term and the first term. So the second term in this series we knew was 1. The first number in the series was 1. 1 plus 1 is 2. So now that I know the third number in the series, I can now find the fourth number in the series. What's the fourth number? That's the third number plus the second number. So we just found the third number was 2. We were told from over here that the first number is, the second number was 1. 2 plus 1 is 3. And again, I can keep going on and on and on. So I cannot find the 12th number in the series until I know the 11th number and the 10th number. I can't find the 19th number until I know the 18th number and the 17th number. So that keeps going on and on. That's known as a recursive series. Then you had some other questions, some very good questions. Where in nature, again, how the branching in the trees, I'm not sure if you watched the video from Khan Academy. It was very fast. They do a great job with their pictures, but showing how the trees branch off. I think it's 131.5 degrees is the ideal way in nature to survive. Leaves on a stem, pineapple, pine cone. I forgot that honeybees, the family tree of a honeybee is based on the Fibonacci. So where does this get to? I wasn't sure where the rulers came in for your question, but when you're talking about phi, there's a basic symbol, there's a more advanced symbol that I would have hacked up as I drew it. But for the golden ratio, 1 plus square root of 5 over 2, which is also known as the divine proportion. So it's roughly equal to 1.6. What does that mean? It's used in math, art, architecture, and you asked a question about, some of the Greek buildings, the Parthenon, the facade. There's definitely some, golden rectangles, as they're known, which just has that ratio. And what they say by the divine proportion is that it's just very pleasing to the human eye. So, something I saw, and I actually looked at a couple websites to try to confirm what I saw. Way back, I remember seeing something about, we think certain set of people are considered to be pretty if their facial features are in the golden ratio, or the divine proportion. And I believe it has something to do with, obviously, are your eyes, how they fit on your face, where they're aligned. But they say the distance, I believe it's from the eyes to the bottom of your nose, and then your nose to the bottom of your mouth, I believe. And I saw a good website that you guys might want to check out, goldennumber.net, and then the /faces. And there's actually, you can look at things in nature and biology and all sorts of different places that you can look at from there to check that out. And again, artists wanted to make sure that their picture looked good to the human eye, so they studied people's faces. What was the ratio from the top of the forehead to the eyes, so they could draw it the same proportion? What was the ratio of the eyes to the nose to the mouth? And this website actually gets into mouth to the chin and the side of the face, and just how everything matches up. And again, no one's face is the same, but as you start to find patterns, then the artist could use that for the pictures. And obviously, we look at certain pictures and say that's a great picture, and we might look at another picture and say that's an awful picture. So it happens a ton. There's a lot of the golden ratios in the pyramids as well in terms of your building. So it's everywhere. It's a topic I don't know enough about. Hopefully these little things will keep those numbers crunching in your head. Check out thegoldennumber.net. Look at faces on the right side of the website. There's a bunch of different things to click on. Again, pictures of nature, you know, and when we talk about a pine cone or a pineapple, it's not that all the numbers show up, but 2 rows might be 2 of the numbers, like 13 and 21. And then on another shape, there might be 21 and 34. So shells. Oops, hopefully that did pop up on you guys. So hopefully that helps. You know, I'm going to send this to you guys. Rowan, I appreciate the question. Keep searching, keep looking for different information, and again, hopefully I can help. And again, pretty much any information I give you from here on out, and I had to do some research so I could remind myself of stuff I studied 20 years ago, but you know, I'd have to get different videos and websites, and there's a lot of information, and some of the math is above math that I've even done. So, but it's just neat to know that those numbers and those patterns are out there, and even whether we mean to do it or not, that they continue to show up. So, great job, and keep searching and keep those numbers going. And hopefully, one of these days I'll get a chance to come down and see what you guys have looked at, and see what material you have for me, and see what questions you have for me. I might have more questions for you. All right, Rowan, thank you.